Good morning, my dear friends. Today, we will be discussing combination of different stresses come in design of cement concrete roads. Yes, in this combination of different stresses, interior edge loading and corner loading you need to be studied, and after that, the warping stresses are to be studied. And considering loading stress and warping stress, the combination of stresses can be identified. In our yesterday class, we have discussion on temperature stress and frictional stress, warping stress. As per the Westergaard equation, he has given three equations for normal stress calculation and three equations for warping stress calculation. In our previous class, we have discussed and solved one numerical for warping stress. And now moving to the frictional stress. Before start of the frictional stress, you must be able to identify what is normal stress and what is warping stress. Yes, as you all know from this equation, we have calculated normal stress at interior, normal stress at edge portion and corner portion. Yes, also by referring IRC guidelines, IRC charts, we can calculate the stresses, different stresses at interior, edge and corner. And after that, warping stress based on the warping down and warping up of the cement concrete slab, or we can call it as bending down and bending up of the concrete slab because of the expansion and contraction or temperature variation on concrete slab. Yes, by consideration of warping down and up, the stresses can be calculated in a warping condition, that is warping stress at interior, warping stress at edge portion and warping stress at corner portion. Yes. By knowing this, normal stress and warping stress, the frictional stresses, the further part is frictional stresses. You just imagine concrete slab is constructed on subgrade. If the concrete slab is constructed on subgrade, there will be two layer formation or two layer construction. One is subgrade, and above that concrete pavement will be there. So there must be a frictional force or friction between two layers. That is, one is concrete layer, top layer, and bottom layer is subgrade. So we need to get the friction between concrete and subgrade, or else what happens, due to temperature variation, due to movement of the vehicles, there will be chances of movement of concrete slab, forward movement, usually forward movement of concrete slab, because of contraction and expansion. Because of temperature variation, uh, there may be chance of rise and fall in temperature, that that leads to overall expansion and contraction of the slab. As that expansion and contraction slab is directly contact with the soil subgrade or lower layer. If it is constructed on subbase, if the concrete slab is constructed on subbase, then there must be a frictional stresses developed between concrete slab and subbase. Usually, because of temperature variation, there is a chances of slabs movement, and if there is a provision of proper friction between two layers, then we can avoid the movement of the slabs. We can prevent the movement of the slab by inducing frictional stresses in the bottom layer of the cement concrete pavement. It means there should be a friction developed between uh, bottom layer and top layer. How we are going to identify the friction? Yes, here is a equation. SF is equal to WLF upon 2 into 10 raised to 4. Where here this equation is formed by equating total force developed in the concrete area or cross section of concrete area due to movement and frictional resistance due to subgrade in half the length of the slab. Here, how they consider? They consider total width of the road and half the length of the slab. Suppose the concrete slab is having width of 3.5 meter and the length is 7 meter. Then we consider 3.5 by 3.5. Then we equate it and get the frictional stresses. Directly, we just refer the formula SF is equal to WLF upon 2 into 10 raised to 4, where SF is unit stress developed in cement concrete pavement and W is unit weight of concrete, about 2400 kg per meter cube. That is load by density. F is coefficient of subgrade reaction. Maximum value is about 1.5. L is slab length. B is slab width. By equating these two, we will get the formula, that is SF equal to WLF upon 2 into 10 raised to 4, where you must be know these unknown thing, where W is unit weight of concrete, L is length of the slab, and F is coefficient of friction. By knowing this, you can calculate frictional stress. Now, where you are going to apply this frictional stress? During the calculation of total stresses induced or total stresses calculation in a cement concrete pavement, you must be able to calculate temperature stresses, warping stresses, and frictional stresses. Combination of these three stresses, combination of three stresses, that is load stress, warping stress, and frictional stress. Combination of these stresses can tell about the critical condition of cement concrete pavement. Yes, how the critical condition of the cement concrete pavement can be determined? It is based on the seasonal factors. Seasonal factors. What are the seasonals? During summer season, what happens to the cement concrete slab during summer season? During summer season, the critical combinations at interior and edge region during midday occurs when the slab tended to warp downward. You just imagine if it is a summer and midday in the sense the time between 12 to 3 o'clock. The critical combination, what are the critical combination during that season and midday? During these days, what will happen? The top layer of the cement concrete will experience highest temperature of an average season. During that time, usually the concrete will or the slab will tend to warp downward. How it causes? Because of expansion of concrete. Because expansion of concrete, the slab will warp downward. Warp downward. And here, during this period, maximum tensile stress is developed at the bottom fiber due to warping, and this is cumulative with the tensile stress due to loading. As if there is a maximum temperature in midday and slab is tending to warp downward, this causes the tensile stresses. Tensile stresses developed at the bottom fiber or bottom layer of the slab. However, the frictional stress is compressive during expansion. If the slab is expanding, there will be friction. The friction will be formed between concrete slab and subgrade. Between these two layers, the friction stress will act as a compressive force, compressive stress. As compressive. If the concrete slab is expanding, then frictional stress between concrete slab and lower layer will act as a compressive. Okay. The load stress at edge region is higher than the interior. Yes, usually the warping downward causes at the edge portion and corner portion. So the load stress will be higher comparing to the interior. Yes, in this season or in this summer season, what will be the critical combination of stress? Critical combination of stress is can be written as load stress plus warping stress minus frictional stress. It indicates what? Load stress is applied through the vehicle or whatever the type of load applied on the concrete slab plus warping stress. because of summer season and more temperature, and the concrete slab tend to warp downward. So there is an increase in warping stress. So what I will do, load stress plus warping stress minus frictional stress. Why I am going to subtract frictional stress here? Because of warping downward, there will be more friction. There will be more friction between slab and the subgrade layer. So hence we cannot be. Hence I neglect frictional stress. By neglecting frictional stress, I can only calculate load stress plus warping stress, because uh, there will be a minimum frictional stress developed between subgrade and concrete slab at edge region. Going to the during winter season. During winter season, the critical combination of stresses at the above regions occur at the bottom fiber when the slab contracts and slab warps downward during the midday. Yes. During winter season, what happens? During winter season, the combination, how we can consider winter season, the temperature usually at the bottom of the concrete slab during midday, because there will not be any temperature from the environment. So the frictional stress is tensile during contraction. During contraction of the slab, the tensile, because of winter season, the slab will contract, not expand here. It will contract. Because of contraction, the frictional stress is, it act as a tensile stress. Hence the combination can be written as load stress plus warping stress plus frictional stress. There will not be frictional stress developed between concrete slab and subgrade. Hence we consider addition of frictional stress. Total is critical stress combination at edge region. Next, going to the corner region, the critical combination occurs at the top fiber of the slab when the slab warps upward during the midnights. There is no frictional stress at the corner region. Usually the load is applied at interior portion and edge portion. It will not be considered corner region. So there is no requirement of frictional stress at the corner region, because more load is applicable on interior and corner portion. So if interior and corner portion frictional stress is considered, then no need of consideration at the corner point. Hence the critical combination can be written as only load stress plus warping stress. It means at the corner region, there is no need of frictional stress. Only consideration is load stress and warping stress at corner region. Yes. And this is what critical combinations in summer season, winter season, and in corner region. During summer season, the concrete slab will expand. Slab will expand. Because of expansion, there is no need of frictional stress. So the slabs are expanding, which forming the tensile stress, developing the tensile stress. Similarly, so the critical combination can be written as load stress plus warping stress minus frictional stress. Similarly, during winter season, the warp will be usually in upward direction against the movement, upward direction. So in during winter season, we can consider critical combination as load stress plus warping stress plus frictional stress. In winter season, uh, contraction of slab will takes place. Because of contraction, there will be less friction between slab and the uh, bottom layer. Hence we consider addition of frictional stress. And in corner region, no need of consideration of friction, because the maximum load is applied at the interior and the edge portion. Hence we take critical stress combination as load stress plus warping stress. Yes. Let us take an example. I will read the question. A CC pavement slab of thickness 20 centimeter is constructed over a granular subbase having modulus of reaction 15 kg per centimeter square. A slab thickness, that is H value, is 20 centimeter and modulus of reaction K value is 15 kg per centimeter square. The maximum temperature difference between top and bottom of the slab during summer day and night is found to be 18 degrees Celsius. What he has given, temperature difference directly he has given as 18 degrees Celsius. Okay. The spacing between the transverse contraction joint is 4.5 meter, and that between longitudinal joints is 3.5 meter. Yes, the spacing is provided for expansion and contraction. In transverse direction joint, 4.5 meter. The spacing between transverse contraction joint means every 4.5 meter the contraction joint is provided. It means the 4.5 is considered as in x direction, and that between longitudinal joints in a lengthwise of the slab, it is provided at a 3.5 meter. The design wheel load is 5100 kg. Radius of contact area is 15 centimeter. Modulus of elasticity 3 into 10 raised to 5 kg per centimeter square. Poisson's ratio 0.15, and coefficient of thermal expansion of Cc 10 into 10 raised to minus 6 per degree Celsius. Friction coefficient 1.5. C. Read the question. Using the edge and corner load stress charts given by the IRC and chart for a warping stress coefficient, find the worst combination of stresses at the edge. Here, at the edge portion, you need to calculate worst combination. To calculate that worst combination, what I want load stress, I want warping stress, and I want frictional stress. By using edge and corner load stress chart given by the IRC, we can calculate edge load and corner load. Yes. Let us start with the solution. In this solution, first we consider edge region. Edge region, what I need to see the edge region chart is just to go back to edge region chart. Yes, it is edge load stress. In this edge load stress, what I need, I want slab thickness and I want K value. If I know K value, that is modulus of elasticity K value, and slab thickness H value, I can calculate edge load stress. See here, for example, here to here and here to here, I will get this edge load stress. Let's see what are the given thing. Here H is 20 centimeter and K is 15 kg per centimeter cube. Let us see H as 20 centimeter, K as 15. Yes. H as 20 centimeter and K as 15 centimeter. 15 means second line. This is second line for 15. So 20, and here I come. Somewhere 24. So I will get 24 kg per centimeter square. Similarly, next, moving to the warping stress at edge portion. Radius of relative stiffness L can be calculated by formula 3h cube upon 12k 1 minus mu square whole to the bracket whole raised to 1 by 4. Yes, substituting value 3 is there. E 3 into 10 raised to 5. What is 3 into 10 raised to 5? E value 3 into 10 raised to 5 into H value 20. 12 into K value is 15 and mu value is 0.15. You will get 60.8 centimeter. Now, the length of the slab Lx is 4.5 meter in a transverse direction, every 4.5 meter interval. That is 4.5 meter. That is can be written in centimeter, 450 centimeter. Now, Cx can be calculated by Lx by L value. Lx by L value, that is 450 divided by 60.8. I will get 7.4. And Cx value, how to see the Cx value? By taking this 7.4 value. Yes, Lx by L value is 7.4, somewhere here. somewhere here, and here to here it will cut, and here it will come and join. That is somewhere 1. Yes, he has taken Cx value is 1.02. Similarly, Ly by L. Ly by L is 350 centimeter divided by 60.8. We'll get 5.75. And let us check the Cy. For 5.75, he 5 is here and 5.75 will be here. Okay, at this point, somewhere here, near around 0.8. He has taken 0.87. Yes, it is correct. Now we are getting Cx value and Cy value. Next step is to warping stress at edge portion. Warping stress at edge portion. STE is equal to EET upon 2 into Cx, because Cx value is higher here. Highest value you need to be considered here. If Cy value is higher, EET upon 2 into Cy will be the formula. Since Cx is the highest here, so I will take Cx. So 1 by 2 E into E into H, T, that is temperature difference, into Cx. We will get 27.54 kg per centimeter square. This is what? This is warping stress at edge portion. Next, frictional stress. Frictional stress, as we know this formula by the previous discussion, Sf is equal to WLX F upon 2 into 10 raised to 4. Here W will be the total wheel load 2400, and Lx, L will be the length of slab, but here we consider in x direction, that is 4.5. 4.5 meter is the in x direction, that is the interval between contraction joints. Into F will be the 1.5 divided by 2 into 10 raised to 4. We will get 0.81 kg per centimeter square. This is frictional stress. Next, by taking this warping stress, frictional stress, and earlier calculated from the chart, that is load stress, the combination can be written here. Combination stress at edge region, critical combination of stress during summer midday is equal to load stress plus warping stress minus frictional stress. Yes. Here summer season minus frictional stress. So hence 24 plus 27.54 minus this frictional stress. Hence we are getting the combination stress at edge region is 50.73 kg per centimeter square. Like that, edge is calculated. Like that, corner region can be calculated. Corner region. Coming with a corner region, load stress. Again, by referring the chart, we can calculate corner region. Take the reference of H is 20 and K is 15, and come to chart. Yes, this is H, and here is corner stress. H is 20. H is 20 and K is 15. Again, second line, and you will end up here 28 or 27. Yes, for corner region, load stress is given 28 kg per centimeter square. Similarly, warping stress equation for corner region is ET upon 3 1 minus mu root A upon L. Substituting E value, substituting small e value, and T temperature value, mu value. A is radius of contact area given in question 15, and L is radius of relative stiffness 60.8. Together, substituting, you will get 9.15 kg per centimeter square. Next, frictional stress. This is 0 at the corner region. As we have discussed earlier, at corner region, there is no consideration of friction. Hence, they have taken corner region stress as 0. Hence, the combination of stress will be load stress plus warping stress. That is 28 plus 9.15. Hence, you are getting 37.15 kg per centimeter square. It means this is the combination of stress at corner region, and this is at edge region. Is this clear?